We're going.
Good afternoon, everyone. I'm Kelly LeCount, PCI's Education and Training Director. On behalf of PCI, I want to thank you for joining us for the Real Cost to Powder Coat webinar presented by Mike Withers, Architectural Segment Leader for Axalta Powder Coatings. Before we get started, I just want to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the Q&A panel. Mike will address the questions at the end of the webinar. If we run out of time, you'll have the opportunity to connect with Mike through email after the webinar. This webinar is being recorded and will be available through the PCI store within 2 business days. All of the attendees will receive a brief survey after the webinar. Please take a few moments and reply to the survey. We appreciate your feedback as PCI continues to develop new programs and offer the topics and training that you need. Now I'd like to introduce our presenter for today's webinar, Mike Withers. Mike has been in powder coatings for 20 years. He has sales and technical support experience in powder coating and electrodeposition coatings. He works closely with R&D to develop innovative products to help solve customer problems. He currently serves on the PCI Board of Directors and is the chair of the PCI Promotions Committee. Mike is also a qualified PCI speaker and presents at our training workshops and technical conference. Mike, it's all yours.
Very good. Thank you, Kelly. And welcome, everyone. I hope that you can hear me well. If you're having any issues with connectivity or you're having any other kind of issues with the technical component, please type into the chat box and James will assist you. Thank you for taking the time. I know these are strange times, and I think everybody is looking to find ways to maybe distract themselves a little bit and learn something. Take this opportunity during some downtime to learn some things that maybe they didn't know, or maybe just have a new look at things that they are working with on a daily basis. And so what I'm going to talk about is the cost of powder coat, but I'm also going to talk about some of the background information. And so why are certain things a certain way? And I'm going to start with performance specifications. And you know, a performance specification generally will take into account the in-use environment. And so if you've got a product that's going to be indoors, it's typically not necessary to have a 1,000-hour salt spray specification for that particular product. Weathering, natural and accelerated testing, you know, that's for components that typically are going to go outside as well, unless you're exposing them to fluorescent type lights. And then the corrosion, obviously, those would be things that are typically going to be in the environment. And there are some environments that are more corrosive than others. Mechanical properties, you know, impact, crosshatch, mandrel bend testing, all of these performance performance specs for mechanical properties. You can over-engineer a coating that will increase the cost of the coating, because that's kind of where I'm going with this. So chemical resistance as well, it's listed there. But if you've got a coating that you engineer for the wrong in-use environment, then you can add cost to a product without even trying. Now, there's all other ways with performance specifications. The customer's not paying you typically for an over-engineered coating, unless you have quoted that product that way. Then typically you're using standard products, and if you're using a product that is over-engineered, then you're increasing your cost and reducing your profit. The other thing is an open communication dialogue between you and your customer for reasonable expectations for coating performance. That's going to significantly impact what you have for rework. And so if you have boundary standards with a customer, and the customer says, hey, this many defects is okay, but this many is too much, now you have and your team have the opportunity to determine which are good products the first time through and which products are going to require rework. And if that's a reasonable expectation and both parties have agreed to it, then obviously there is a way you can save on cost. Now I'm going to talk briefly about some of the chemistries that are involved, and some of you probably all know this all very well. This may be new to some of you, but epoxies and hybrids are for indoor use only. They're not stable in UV exposure. They have the best corrosion properties, and a lot of that is because how they cross-link, but they're often used as a primer. And so there will be a polyester top coat that will be applied to it if it's going to be something that's going to go outside. As I said, they have excellent chemical resistance, excellent hardness and mar resistance. They have excellent post-forming properties, and they have low cure and low film build available. So you can go under 1 mil if you need to go under 1 mil, or you can have a very smooth film as well. The other opportunity with epoxies and hybrids is that you got the full range of gloss, and so you could go from a dead zero gloss all the way up to a 90+ gloss. The next products I'm going to talk about are polyester TGICs, HAAs, urethanes, and then we're going to get into super durable. So polyester is the backbone resin. For thermoset products, we have to have a curing agent, and the curing agent in TGIC is the TGIC. It is a non-mutagen, and so in other parts of the world, they have stopped using polyester TGIC products. In the US, it is still being used. In fact, it is probably the most used. It is the workhorse. But it is also, because it can go indoor or outdoor, it gives it a lot of flexibility. It can be applied at higher film builds. It's got good weathering properties. It's got good corrosion resistance and flexibility and smoothness. For the HAA curing component, so you'll hear that referred to as a non-TGIC or TGIC free, or just simply as a polyester HAA. They're more environmentally friendly. The curing agent only releases water, and they can be also applied at higher film builds. Initially, you could not do that, but there have been recent advances in the last couple of years where you can apply at a higher film build. They have excellent charging properties, and so if you're typically using a TGIC polyester and you make a conversion to an HAA, then you're going to typically have to turn down gun settings because they have such excellent charging properties. So that means wrap around the part and then Faraday cage penetration. They too have good weathering. They have good corrosion resistance. They have good flexibility, and they have good smoothness. They are limited, both of those, polyester TGICs and HAAs, typically to about 25 is about as low a gloss as you can get, but you can go to full gloss of over 90. Now, urethanes, they also can go indoor or outdoor, but they are much smoother. They have a blocked curing agent, so there is some fuzz. If you notice around the entrance and the exit of the oven, you'll see some brown fuzz. That's the covering on the curing agent that releases at the right temperature. There can be some odor with these. You will notice the smell in the air as the product is baking. But the very low gloss, now, we talked earlier about epoxies and they can have the full range of gloss. Urethanes have that full range of gloss as well. So if you're looking for a product that polyester TGICs and polyester HAAs cannot achieve, a urethane may be an opportunity for you there. Super durable only means extended weathering. So there is a lot of misinformation, I guess, around it. People have misconceptions about what super durable means in coatings, but what it means is that it's going to have better gloss retention and color retention over time in the sun. And so the other part of super durable is for a product that get both of those attributes, then all of the raw materials, and we're going to talk about those in just a minute, have to be rated for super durable use. Some of the other products that are out there are fluoropolymers, typically used in monumental architecture. However, a customer may tell you, if you're a coater, say, I want the best coating out there. Well, depending on what you're looking at in the end use, a fluoropolymer can be the best coating out there because it gives you the longest performance in the sun. But it is also significantly more expensive than a standard polyester TGIC. So in that case, you may be over-engineering the product. You don't need the fluoropolymer and increasing the cost. Metallic effect, there's 3 ways to produce metallic effect products. Extrusion is the first, where we put everything into the same hopper at the start, and it goes through the extruder, which is what causes us, that's how we make powder. The extrusion process, however, is pretty aggressive to the pigment, and so it kind of beats the pigment up slightly, and you don't get as a desirable metallic effect. A dry blend is another way that can be done. So you create a base color, and then you dry blend in, or just thoroughly mix the metallic pigments in. That is a little bit more expensive than the extrusion process because you're having to do another process to produce it. And it's not as stable. So that product, if you're trying to reclaim, typically you would not try to reclaim blended products. In rare occasions where the metallic content is very, very low, and you're reclaiming through a cartridge system, you may be able to get away with it. But that's another way that you can start to look at your cost to coat. If you have the ability to reclaim, or the capability to reclaim, and you have the equipment that can do that, then you can lower your cost by not spraying to waste. Spraying to waste, as you know, you're going to discard powder. And so if you're going to reclaim metallics, we typically recommend that you go to a bonded product. And bonding is desirable for every reclaim application. It is the highest cost, but it is the most consistent in appearance. And it does that with the products that are available in the marketplace. We can achieve a pretty large spectrum of metallic appearance. Liquid coatings have an opportunity, because it's 2 and 3 layers at times, to do some things that we're not able to do because of the way the metallic pigment lies in a powder coating or orients in the film. They can do some things that we can't do. They can load more pigment particles into a formula. But we are able to achieve some really nice appearance products with metallic bonded product. There are high temperature coatings. That another is a very high cost product, but it is a specific use product, and so you would not use that for general products. You'd only use that where the in-service temperature of a product is elevated. Antimicrobial is very appropriate today. It's another process. It actually, in some of those instances, it's a bonded product as well. We do give the disclaimer: it does not kill bacteria, but it does not allow it to replicate or feed. And so those products, any public application where you're having a lot of different people touching a surface, doorknobs, push pulls, handrails, things like that, that's a good product for that. But it also significantly increases cost. And so you would not typically use that in an application where you did not need that. Outgas resistance, that is something that really can impact your cost. So if you're painting a lot of castings have a especially nowadays, castings have a lot of recycled metals in them. And even the process of creating the casting, it will trap gases down into the component that you're trying to, or the cast component you're trying to paint. And so those gases like to come out at the temperature we like to cure powder. And so you get pinholes, and then you have to go back and rework those oftentimes. We can build into a formula outgas resistance to help with that. And so there's another case where you wouldn't use an outgas resistant product unless you have a substrate that is subject to outgassing. Briefly, we're going to talk about the weathering performance. And so this is where that super durable really starts to take effect. It's the middle graph on both sides. First one is gloss. You can see that a standard polyester that's exposed in South Florida, and this is natural exposure, that's our most harsh environment in the United States. And in fact, it's one of the harsher environments in the world. So many of the other countries, they send products here to be tested in South Florida as well. Now, if you think of a project or an in-use service of a product that is not going to be in South Florida, say if you're north of the Mason-Dixon line, then those products see significantly less UV exposure. And so would you need a super durable product if you are not getting the intense UV exposure that you get down in Florida? Now, if you've got products being shipped all over the country, you pretty much have to go that route because you are going to be exposed to it at least at some point in time. On the other side is the color variation, and that's typically measured in what's called delta E, and all that really is a measurement of one color position to another color position over time. And so we're exposed to the outdoors. You can see the one, and after 2 years shifts about 2.5 color units. The middle one is just over 1.5, and the last one, which is the fluoropolymer over there, you can see it's very stable. Back to the gloss side, you can see the same thing, that the gloss was the fluoropolymer is that one that retains its gloss significantly well even after 10 years of exposure. But again, as I said, if your in-service use of this product doesn't require that, you can significantly increase the cost to coat. So we're going to talk a little bit about applied cost, and many of you, I'm sure, have already heard about applied cost, but this is where you take effectively, you use the technical data sheet that the paint manufacturer supplies you to understand what does it actually cost me to apply powder to a part. Now, this still does not consider rework, labor, all the other stuff that's involved, but you can see the simplified version of the formula on the screen now. I'm not going to read through it, but it's good to know what the background is, because what we actually have is a calculator, and we're going to access that on the powder coating website, Powder Coating Institute website here shortly. And so let me go back and talk about formulation a little bit. So when we create a formula of powder coating, or our chemist does, the formula has organic polymers. That's your polyester resin. It could be an epoxy resin. Could be an epoxy and a hybrid. I mean, epoxy and a polyester resin, which is what we call hybrids. You have extenders. Extenders are in all formulas. You have pigments. You have flow and leveling aids, anti-cratering, and then there's other additives. You know, things that maybe kill gloss if it's a formula that kills gloss, things that maybe create texture if it's supposed to create a texture. All those things can be in that additive component, but the vast majority of a formula is going to be the polymer. And then you got a little screen down below that just kind of shows you the manufacturing process. And I don't think I can, maybe I can use my pointer. I'm going to use my pointer just to show you. So we have the formula here, and you see these components. All of this stuff goes into a bowl. And so we take all these raw materials, we put them into this bowl on a scale. Everything's weighed up for the amount of product we're trying to produce. And then it's flipped upside down, and it's pre-mixed. And basically, each one of those raw materials stay in their original state. They're just blended homogeneously through a mixer. You can think of it like your KitchenAid mixer at home, and you know, you've put all your dry components in there, and you've pre-mixed those before you put the wet agents in there. And so you see a step one there, and so what that is we're actually doing a check there for, you know, if we take this product into the lab and we extrude it, grind it, and then spray it out, does it look right? Because we have the opportunity while they're in their raw components to modify the product if it needs to be modified. The premixer is then turned back upright, and it goes through an extrusion process. And you can see the extruder there. I know it's kind of small, but hopefully you can see it. We'll also do a check there for quality. As it comes out of the extruder, it's a hot melted product. It hits some pinch rollers that are cooling it, spreading it out into a sheet, and it goes down a cooling belt. And then it goes into a grinder. We do a check there. It goes through a sieve, and then it goes into boxes. And so that's the process for making powder if you did not have exposure to seeing that process previously. So why do I say all that? I say all that because specific gravity. You know, so on your TDS from every supplier is going to be listed the specific gravity of the product that you're buying. And so a formulation can have more or less extender in it, and extenders are typically in all formulas. They do have a purpose in formulas at times as well, but extenders do not charge well like resins do. And so if you use more extender in a formula, you can typically reduce the overall cost of the powder coating. But what you are hurting in that process, or impacting negatively, is the sprayability of the product. And so you are going to, and we'll talk more about this, but it's going to be harder for the sprayer. Whoever's on the gun, they're going to say, you know, I really have to work to get the powder to stick to these parts. And so oftentimes you run and go look to see if I've got a ground issue, and it's not a ground issue. And then they said, but this other powder will jump on a part. And so what that is an indication of is that you've got a higher specific gravity formulation, in that case most likely. Now there are some colors that require more pigment than other formulations, and so you're going to see higher specific gravities for a white, for example, than you will typically for a black. But conversely, less extender in a formula means a more resin-rich formulation. It's got better charging, but it does increase cost. And so this specific gravity component is going to go into a formula we're going to talk about, but it actually, with that formulation, a resin-rich product, you typically do get better Faraday cage penetration and provide better wrap. And then less extender improves the transfer efficiency. So all of these things that are impacted in that formula you saw just briefly is impacted by specific gravity. We talked about throwing it away. If you spray to waste, you're discarding powder. A good ground is key to a good transfer efficiency, and gun settings play a key role. Do a simple math here. If you go from a 40% up to a 60% because you do some things and have an impact on how you spray, then obviously you've got an opportunity. If you spend $100,000 a year in powder, then you got an opportunity to save $20,000. Just by changing how you do things, you can put $20,000 back in your company. The next thing we're going to do, we're going to actually go through an example. So I want to give you a real world example. Oftentimes, if you're in your office and someone comes in and says, hey, I've got a product here I can sell you. This is a 1.6 specific gravity. It's $3 a pound. Okay, well, is that good or is that bad? And so what we're going to go through is an example here where, well, let's say you got a really good system. You're getting about 70% transfer efficiency. And we're going to go to the PCI website now and kind of go through the process. And the reason I want to do this is because, when you're in your office, you've got the ability to go back to the website and use this calculator yourself. And I will say this: you are able to also download the app. And so the app itself, you could download to a smartphone, and you can do the calculation anywhere out on the floor if you desire. So what we're going to compare is we're going to compare a 1.6 specific gravity to a 1.3. They're both going to be applied at 2.5 mils. The cost is different. Remember, I talked about the lower specific gravity is likely to be higher cost. So we're talking 30% more in cost. And so let's jump to the other site. So this is the Powder Coating Institute main page. If you go over to resources, and you can see all the items there, the next to last one is the Coatings Comparison Calculator. If you click on that, it takes you to this screen here. Now, I will point out that there is a blank comparison tool here, and then there's a comparison tool with an example. This is a very, very detailed comparison. This one you're getting involved in how many BTUs is the oven, cost of air, compressed air, all those things. Really, I mean that's a very detailed. So, if you're looking for that type of a comparison, then that is available there. But for most of us, what we're trying to find out is what does it cost me to use this paint, and how much does it cost me to put it on each square foot of the parts that I paint. And so you go to this place here where it says click here, and you do have to click here. You can't click anywhere over here. You have to click on the here. But when you do that, it takes you to another page. Now, if you're in a situation where you're trying to compare a liquid cost to a powder cost, you have the capability to do that. You can do a liquid calculator and then compare it to a powder, or you can do one powder to another. And so that's what we're going to do today. And so let's start with the first one. It's 100% volume solids because there are no liquids in a powder coating. The efficiency, we said for our example, is going to be 70%. The specific gravity for the first one was 1.6. It already is telling you here that you're 84 square feet per mil per pound. Film powder cost was $3 for this particular example. And then the film thickness is 2.5 mils for both of them. And so from this, we see that our applied cost, what does it cost us to paint parts, is 8.93 cents per square foot. Now let's compare that to another powder. So again, we're 100%. Efficiency still 70. Specific gravity on this, oops, hit too quickly, is 1.3. Now you can already see the lower specific gravity gave us more square feet per mil per pound, or per pound per mil. And in this case, the cost was higher, 330, and the film thickness is the same at 2.5 mils. And so now you can see this is 7.93. So let's see the comparison. So you can see the coverage. We get more coverage out of the lower specific gravity, which is what we expected. It was a higher cost, but look what happened here. So now your cost per square foot is, and I know this is 1 cent, but if you're coating millions of square feet of product a year and you can save a cent, you can make a real big impact on what your cost to coat is. So I'm going to start over. Well, I'm actually going to jump screens one more time, and then I'm going to come back because it actually comes up on the next screen. And so we're going to talk about the impact of film build. And so this one is one that we see, we're going to go back to that example again, and we're going to change film builds, and we're going to see what that impact is. But it obviously makes sense that if you put more on that's required, then you're going to be increasing your cost. Well, the TDS tells you also that the recommended film thickness from the manufacturer. And so if you've got a recommended film thickness of 2 to 3, and sweet spot in the middle is 2.5 mils, and you're able to control that versus someone who is putting on 3.5 mils, then you've got an opportunity to have a lower cost. So the film thickness is going to be the only variable. Cost per pound of material utilization, everything's going to stay the same. And then we're going to look at how that impacts the cost. Now, the question I'm putting here is, how did you quote the customer? And so if you quoted a job at 2.5 mils, and why do we put more than 2.5 mils on parts? Well, oftentimes the feedback to the people on the powder gun is that, hey, you had light parts, we have to rework these parts, don't do that again. So the tendency has been to put too much powder on parts, and we see that pretty much industry-wide. There are some industries that measure it very closely, but we see oftentimes we're putting on more than we need to. Now, there's some cases where you have to, where you have a Faraday cage area, and you're going to have, the areas that are closest to the gun are going to have a slightly higher foam build to get the minimum down into the recess areas. But one of the things, if we're really looking at this and we're controlling our application film builds, then we've got an opportunity to maximize our profits. So we're going to jump back to the website real quick one more time. And we're going to do this same example. We're going to start over. And I hope that you get comfortable how easy it is to use this calculator and how quickly you can determine at your facility, what are my costs to paint? So I'm going to go back to the first one, the 100% solids. This one was a 70% efficiency. This one was a 1.6 specific gravity. It was a $3 per pound cost. It was an applied film thickness of 2.5 mils. And so just so you can remember, we saw this was 8.93 cents per square foot. So now let's just real quick jump down and say, well, what happens if we're putting 3.5 mils on? Now you can see the comparison. So we went from 8.93 cents per square foot to now 12 cents per square foot. Now that's a hidden cost, and I say it's hidden because you really are paying it, but it's not one that you see right up front, because if you're not measuring film builds and you're not controlling film builds, then it's just presumed that if you quote a job at 2.5 mils, you're presuming that you're going to put 2.5 mils on. And so that was a pretty big difference there. So now let's go back to the other example. It was a 1.3 specific gravity. And it's already showing you, I tipped my hand too quickly. 2.5 mils, excuse me, cost was different. Let me get to the cost, 330. So this was the second example with the lower specific gravity. And so now we're going to go from 7.93 cents to 3.5 cents. So now we're making that big of an impact. I mean, almost, I do the math in my head, but a little over 3 cents, maybe approaching 4 cents per square foot. And so that's a significant cost difference. Now, real quick, I want to jump in and just change one other thing and kind of go back to our original example. So I'm going to go back to the 2.5 mils. I'm going to go back to the 1/6 specific gravity. And I'm going to go back to the $3 a pound cost. And let's see, what is the impact of all these things I've been talking about if I am doing reclaim? And so let's presume that your reclaim is really efficient and you're approaching 95% transfer efficiency. Excuse me, your coating process is very efficient and you've got a 95% efficiency. Here you see that the cost has gone down to 6. And now, if you remember, that was the 8.93. So that's a significantly different applied cost per square foot. But I can just quickly show you on the screen that if we change that specific gravity, and that's well, we're going to have to change two things. I'm sorry, got to change this too. And then the cost. Now we're at 5.8. If you want to see the comparison, I can go back and do that real quick. 100%. This one's a 95%. This is a 1/6 we're comparing it to. That cost was only $3 per pound. And the applied film thickness is 2.5 mils. And see the comparison. And so again, and I reversed them this time. So that's why this one looks cheaper. This is the lower specific gravity over here. So the 5.8 is still about half a cent per square foot cheaper. But it also still shows you that the lower specific gravity product, even at a higher price, can have a lower applied cost. Let me check and see how I'm doing on time here. I'm good. Okay, so I'm going to jump back. Well, let me do one other thing real quick. Let me show you that the difference between the cost of putting too much paint on in a reclaim process, because oftentimes we hear that, well, I'm reclaiming powder, it's okay, but put more on there, okay. Let's go back through that and see what specific gravity, the first one was 1/6. The cost of the first one was $3. And the applied film thickness is 2.5 mils. So we're back to the 6.5 cents per square foot applied cost. If we vary the film thickness on this case, so we're not controlling film build, and we go to 3.5, so it's 6.5 cents now, it goes to 9. So now you can see the significant impact of film build on your applied cost. And so are you planning for that? When you quoted the job, did you quote for that? When you ordered paint, did you order enough paint for that? That's another way to add cost. If you have to break out of a product because you run out of paint and have to wait and order more, now you haven't delivered the customers the parts when they asked for them or expected them, and you're having to do a color change in the process, which is going to add cost to you as well. Jump back over to the other screen. So you got to see how the applied cost has an impact. And so even just doing simple math, and so this is probably a high number, but recent advancements in the industry producing these non-contact film thickness gauges. If you haven't had an opportunity, if you're at the PCI Tech Conference, if you're at any other conference where you get to see this measurement equipment, if you're attending a training class, once we start in-person training again, you'll have an opportunity to see these. But these are getting better every day. And so if you have a job shop and or a coating operation and you're spending $300,000 a year, if you're putting on 3.5 and you could be putting on 2.5, that's a mil too much, or that's 40%. 40% of 300,000 a year is a potential savings of 120,000. So now, yeah, is that a good investment? And the reason I put this on here is there's been many times I've been to customers and working with them and that aren't using a film thickness gauge, and you try to show them the benefits of doing that. And I've often gotten the feedback that says, "Oh, that's too expensive. I can't afford that." You know, my argument to that was based on this: you can't afford not to use this. It's the payback on this is so short that it makes so much sense. The other advantages of using lower film thickness, as you increase film thickness, especially if you get significantly thicker, you start to negatively impact the mechanical properties of coatings. And so you don't want to do that as well. You don't want parts chipping off as they bang into each other or as they bolt up. So one of the other subject I want to talk about is line density. So I've been in many facilities where you see a conveyorized line and you see one part on one hook, and then you see some distance between them, and then another part on another hook. And these parts typically aren't that large. And so, you know, if you've got and we talk about the window of opportunity, and you'll hear that if you've been to training classes, you'll hear that term used. You know, how many parts can you fit into that window of opportunity? So with the guns that you have, with the line speed that you have, do you have manual touch up? You want to maximize the number of parts that are in that space. And so if you had one part for a hook, in this example, I'm showing 8 parts per 12 feet of conveyor, 8 parts per minute, and 3,840 parts per an 8-hour shift. Okay, but if you hang one above the other, now you can double the number of parts in an 8-hour shift. You can also double your revenue. And the other benefit of that is that you've got the opportunity to move on to another color. And I think I get into that on the next. Yeah, it does. Okay, so let me get into that. Increasing line density increases first pass transfer efficiency. If you are spraying paint into air, even if you're reclaiming, but especially if you're not reclaiming, you are wasting money. You want that powder cloud hitting as many parts as possible. Increasing transfer efficiency lowers the applied cost. We've already seen that. I showed you the example of a 70% transfer efficiency to a 95% transfer efficiency. If you increase line density, you can move on to another part faster, so you can get more customers. You can change colors for the customer that you have. All of this increases your throughput in your facility. Now, we're all being asked to reduce. I mean, actually, I've heard so many times where an end customer says, "Hey, these parts are on the truck on the way to you. When can I get them back?" You don't even have the parts yet. We're all being, our time is being compressed for all of us. So everything you can do to paint as many parts in as short a period of time as you can increases the profitability of your company. And then obviously spraying parts air instead of parts during reclaim impacts your particle size distribution. Now, we haven't talked about that, so let's do that now. Particle size distribution, if you look at there's an analyzer that measures, you know, particle size in a powder formula. There's not just this one size of a powder grain. There's actually different sizes inside a box of powder, and it looks like a bell curve. And so the one on the left is kind of virgin powder. It's powder that's come straight out of the box. It hasn't been sprayed. You can see that the fines, what we call the fines, less than 10 micron, is pretty small. The sweet spot for applying powder is you know, up here in these areas up here. Everything up above these lines here, this line here is really the sweet spot. Now, as you reclaim, you actually start to, especially, well, and let me back up. This is a cartridge type system example. If you have a cyclone type system, it actually scalps off all the fine particles and you don't see this. But if you had an issue where you have poor fluidization in your reclaim hopper, and then it transfers over in your fluid, your main gun feed hopper, then this may be a reason why this is occurring. As you build up fines in the system, they do not like to fluidize. They do not charge well. They don't accept the electrostatic charge very well. So they're basically just taking up space. When you get to this point, we would typically recommend that you run the hopper down as low as possible, and discard that powder and start the process again with virgin powder. Another way to really look at how do you reduce your cost is to be able to measure what is going wrong in your process. And so you have to look at defects. What are the defects? And then understand, okay, well, what kind of rework is involved in that defect? So if it's a light spray product and the powder is able to be reclaimed, or excuse me, resprayed, in other words, you're going to get good intercoat adhesion without doing anything to it. You basically pull the part off the line and you put it back on the line, paint it again. As long as you're in that color. Now you got to add in the cost of doing the color change if you have to go back and do it later. But here's your opportunity now. So if you've got, and many companies in my experience do a really good job of measuring, okay, well, these are the reworks we had, but what we don't measure oftentimes is the cost of the rework. And so if you are having to go back in and scuff parts, if you're having to go in and do something else, if you have to burn off parts, if you have to send them out for chemical strip, if you start to document all those costs and then start to look at what is causing the defect, if you attack the ones that are occurring the most by turning it on and turning off the defect by figuring out the root cause, then you're able to significantly impact the cost to coat. And I'll just give you a brief example. So I was working with a customer many years ago, and the customer understood their cost to coat and told me what they use this many pounds, and they use let's just use some numbers. Use an example of $3.75 a pound and 100,000 pounds a year. So they think their cost is $375,000 a year to paint. Doing an audit process, we determined that they had about 10% rework, and these reworks had to go through a shop blaster. So their cost to rework was significantly higher. I've heard industry experts use the number that 4 times the cost of an original part. It could be even higher than that, depending on the number of reworks or the rework process that you have to go through. So now when you start to look at those numbers for this particular customer, after doing the audit and seeing the issues, they had over $400,000 in hidden costs that they didn't know about. They were paying it, but they weren't tracking those costs. And so as we pointed that out, they were able to make a significant improvement in their cost to coat. Increasing transfer efficiency. This is a really good example. You see the picture on the top. You can't see the booth through the booth. There's this huge powder cloud. There's a part right there in front of the sprayer, but there's as much paint behind the part as there is in front of the part. And so reducing the amount of powder coming out of the guns really significantly impacts the ability to get a higher transfer efficiency. And you can kind of see there that the low feed setting in our laboratory testing showed that we could get 95% plus transfer efficiency. When we turned the feed pressure all the way up, it was about 15%. So in our case, all the powder was hitting 15% of the powder was on the part. The other 85% was on the floor. So you should be able to see through a cloud. And if you are reclaiming, a lot of people say, well, it doesn't matter, I'm reclaiming. Well, we saw what happens to particle size when that happens. And so that impacts your sprayability as well. Keys to improvement. So we're going to treat your paint and pretreatment suppliers as partners. They are experts in their fields. They can help you and want to help you to have the lowest cost. It's in their best interest, long-term interest, to help you be successful. They can help you with training. Coming out of this crisis situation, there may be different people working in different jobs, and they may or may not have training in those jobs. So I would encourage you to have a trained person. It's not only important to know how to do a job, but it's also important to know why you're doing what you're doing. And what happens if you don't do the tasks that you're supposed to do. Because oftentimes they don't understand the impact of not checking something that they're supposed to check. And so I oftentimes argue, who's the key person in your shop impacting your customer's perception of your performance? Well, that's the person on the application gun. Provide training. They control so much of your profitability, your first pass good. All of that is reflection of how well they know how to do their job. Reduce non-productive time. So if you've got long gaps in your line, if you've got lots of line stops, find out why. Why are you having line stops? Is it they're not able to hang parts effectively? Is it they're not able to remove parts effectively because they're still too hot? Look at all those things and then see if you can attack a way to have less non-productive time. And then a batch system, if you had hot rush parts and you had prototype parts that needed to be painting, having a batch booth and a batch oven is a very good way to not break into your conveyorized line. And again, I already jumped ahead, I guess. The line stops, figure out why they happen, make them go away. An example, there was a customer that had typically 12 feet a minute and was very proud of the fact that they were able to run 12 feet a minute. And it's standing there a few minutes, so I noticed that there were several line stops. And so as we watched, the effective line speed was only 8 feet per minute. And after pointing that out, what they actually did was slow the line down to 10 feet a minute. The reason the line was being stopped was because the sprayer couldn't keep up at 12 feet a minute. So how much powder do you need coming out of a gun? At the speed that the parts are going in front of the guns, only enough to get to the appropriate film build on in the time that you have with the guns that you have. Paint improvement. And so coming out all this craziness, I think we've got an opportunity to say, okay, let's push the reset button. Let's find out what we've been doing. Is there a better way to do it? And I think there is. I think there's an opportunity for us to, as collectively as a industry, to try to make things better, and maybe we have to learn how to do more with less people. That might be the case. And okay, well, how do we do that? So we utilize the experts, the technical service folks that are in your suppliers that can come in and help understand what you're doing, how you're doing it. They'll do an audit of your facility and they'll detail the things that you can do to make improvements. And with that, we're going to stop with questions. I ran over just a little bit. We still have time for some questions, but you see my contact information there. I'm happy to answer any questions that you have. So Kelly, take it away.
Great. Thank you so much, Mike. That was great information. We do have several questions here, so I will just get started here with the first one. And like Mike said, if you guys want to go ahead and write down his contact information, that'll be helpful afterwards if we can't get through all of this. But the first one was, Mike, why do people not use polyester TGIC in other parts of the world?
Yeah, so the health risks of TGIC in the U.S., let me kind of back up. The people that actually produce the TGIC product itself are way more at risk than anybody else. The levels that it goes into powder coatings, in other words, the curing component, is so small in powder coatings and the exposure level is so low that it typically is not an issue. However, there are some states that are more aggressive than others on environmental regulations. And so there was a move at one time in one state to require the skull and crossbones on a box of powder that has TGIC in it. That did not happen. The product was delisted. So but it's going to be a lingering issue. And so, many of the companies, the rest of the world, they're significantly more concerned about environmental. And I think that's why it started there. It's really started in Europe, but it's really sweeping across the rest of the world.
Great.
I'll bet it's your question.
Good.
Worker safety.
Right. So can an outdoor powder be used indoor? And what about the reverse?
The answer is yes. The powder, so if polyester can go indoors or outdoors, but the reverse is not the case. If a product is developed for indoor use only, if you put it outside, you will have problems. It will chalk. It gets there, and I think if you've noticed like the pad-mounted transformers in residential neighborhoods, a lot of those things get that real chalky appearance on the surface, and you can wipe it off, but then it comes back. Mm-hmm. So that's a byproduct of the formulation. It's not UV stable. It's not designed to go outside.
Okay, great. And what's the difference between good corrosion and excellent corrosion? Is this a general statement, or can it be quantified by testing?
Yeah, so yeah, it is a general statement.
Yeah.
Corrosion performance is always is a result of the entire layer. And so it's the substrate, it is the pretreatment, and it is the powder itself. Now, any one of those can cause a poor corrosion. If you have premature corrosion in the field with your parts, you have to look at all of those things. And so, you know, pretreatment is, we always say in the industry, powder doesn't stick to metal, it sticks to pretreat unless you're doing mechanical blasting on parts, and then we're sticking directly to the metal with no pretreatment. But so that pretreatment layer is key. You know, there's iron phosphates, there's the titanium, or excuse me, the zirconiums, and then there's the zinc phosphates. And so you can improve each one of those is kind of an improvement in performance. And then with the powder itself, there are powders and there's additives in powders that can be put in there to increase the corrosion performance. And so depending on the application, corrosion is absolutely a product of the entire system.
Okay. So are all outdoor powders glossy, and do they require the high curing temperatures?
That's a good question. No, they're not. Many of the outdoor products are glossy. So if you look at depending on the product, so are you trying to draw attention to the product? If you look at a lawnmower in front of one of the box stores, those are typically very shiny. In fact, they want to be smooth and shiny. They'll often use the urethane technology, polyester urethane technology in those. However, there are some components that you don't want to draw attention to, and so sometimes you see lower gloss in frame components for the lawnmower. So the underside of the lawnmower may not be shiny. So depending on what the desire is or the desired effect is, then you'll have the gloss level change. With polyester TGICs and HAAs, you can only get down to about 25 effectively. If we have to go below that, then we go for a polyester urethane.
Okay. So a couple more just came in kind of on the same subject. Does a powder coating need a primer?
The answer is no. Typically, all powders are developed to go direct to metal, but using a primer will typically, in most cases, increase the corrosion performance of the product. And so, and there's a big difference between, so if you put 4 mils of a film, 4.5 mils of a film, or well, let me back up. Let's say you put 5 mils of a film of a polyester TGIC on a product, and you're trying to get better corrosion performance because you're increasing the film thickness. That's one way to do it. Or you can actually put 2 coats of 2.5 mils to significantly improve the corrosion performance. And so if you're thinking in like industrial applications where there could be acids in the air, there could be exposure to acids spilled on things, or in a marine environment where you're on the coast, boating components, things like that, things that are going to see exposure to harsher environments, which can cause premature corrosion. That's where you would start to use a primer. And we typically would use an epoxy or a hybrid as a primer because they have the best corrosion resistance, and then put the polyester top coat on top of it.
Okay. So another one about the indoor versus outdoor. Somebody asked, are carboxyl polyester for outdoor and hydroxyl polyester for indoor? Is that the difference?
That's a good question. I'm not a chemist, so I won't try to, and I did not stay at a Holiday Inn Express last night, so I would refer you to your paint supplier. Those are 2 different curing technologies, and they both exist in the world. My understanding, and I really don't want to speak to it, because if I tell you something, I'll probably be wrong. And rather than answer that question, you really should refer to your paint manufacturer, and they'll have the chemist answer that question. Ultimately, the TDS is going to tell you if a product is suitable to be used outdoors or indoors, and really whatever the functionality of the resin itself is not going to be as important.
Okay. Thank you. So we did have a question about current times here. Do you have any information on whether or not using the antimicrobial on frequently touched surfaces is effective with COVID-19, as it's as effective with other viruses and bacteria?
Well, I'm not a scientist either, but I can say that we have not tested for COVID-19 because COVID-19 is too new. We have tested recently, or many of the paint companies that produce antimicrobial products have done testing. My company actually did the testing with Rice University, and we are able to provide that information with what was tested at that time.
Okay.
I cannot speak directly to COVID-19, but I do know that we would expect that it would be as effective with COVID-19 as it has been with other things.
Okay, thank you. So what is a good paint for low outgassing or well-controlled, contamination-free environment?
Yeah, so there's additives we could put in products that give you outgas resistance. Some companies actually sell that as a post add. So you put it into the hopper if you've got a product, and so RALs are very popular colors. So if you're buying RALs and then you've got you come across that, some of the parts are cast, so they outgas pretty badly, or they're galvanized and they outgas badly. You've got an opportunity to put an additive into the hopper that is going to improve the outgas resistance. And basically what it does is allow the gas bubble to blow through, and then it refills itself. There are also things you can do from a curing component. So, you know, if powder coatings cure typically in a range, there's a cure window. For a lot of standard products, it's 350 at 20 minutes, 375 for 15, and at 400 degrees for 10. That's part metal temperature, so that means the metal has to reach that temperature, and it's got to stay there that entire time to be fully cured. Well, if you cure a product at the 350 for 20, the outgassing is going to be significantly less from the substrate, and so you have the opportunity to turn down the temperature that you're curing your product at, and extend the time. But if you do those two things, then you can have significantly improved performance. There is also the opportunity to degas the substrate first, and you do that by washing it first, and then putting it in the oven at a temperature elevated above what it takes to cure the powder. So if you had a clean part, put it in an oven at 425, you get it at 425 for 5 minutes, 10 minutes, depending on how much outgassing you see out of a product. You may have to extend that bake cycle, but you get the part that hot, bring it back out, and then go back and put the coating on after it's cooled, and then do a standard cure. So what you're actually doing is getting that part to an elevated temperature, driving the gases out, and then curing it later at a lower temperature.
Okay. Can additives be added to kill the gloss after completing powder's manufacturing?
There are companies out there, to the best of my knowledge, that do that. There are additives that can do that.
Okay. There are a few here on transfer efficiency. So can you tell us what the typical transfer efficiency is in powder coatings and how to measure that transfer efficiency?
Yeah, so it's really simple way to do. There is no typical, because it really depends on you and your transfer efficiency, especially if you're painting on an open floor. Your environment's changing daily. The humidity on a rainy day is going to be different than the humidity on a dry day. The humidity is going to be different on a fall day versus a dead of winter day. If you're in the northern part of the U.S., your winters are going to be significantly less humid, and so the air is going to be very, very dry. And so if you're in if you have an EV room, which is just an environmental room, but if you have a room around your booth and you have air conditioner that is controlling the air temperature and the humidity in the room, and that's ideal, because in those circumstances now you have set points. Especially if you have automatic guns, you have presets on the gun controller. And if you want to have consistent film builds, you got to have consistent temperature and consistent humidity in the environment where that gun's working. Otherwise, it's going to be all over the place, and your people are going to be chasing that, saying, okay, the first part's coming out, are thin, turn the pressures up, and that's typically what people will do. But yeah, transfer efficiency is pretty easily measured. Measure the powder before you spray it. Measure the powder after you spray it. Measure the part weight before you spray it. Measure the part weights after you spray it. Now, you can also do that with the hooks or whatever you're hanging. If you're hanging on a rack with multiple parts, you can measure that. But the idea behind it is how much paint did you spray, and how much paint did you get actually on the parts when you sprayed them.
Okay. So somebody wanted to know if you can just tell us the rough cost of powders.
Yes, that again is all over the place. So
yeah.
I gave you an example that if you have a product that has more extender in it, it's going to be a lower cost per pound. And so powder, we have the opportunity as if we're working with the customer to formulate product that meets your needs. And so, you know, if you've got a low expectation, if the customer that is purchasing your parts has a low expectation for paint performance, then maybe you don't want to have such a high cost product. If you've got a customer that is very demanding, then you're going to have a product that's more engineered towards your needs. If you got product that's in a harsh environment, South Florida, then you're going to need to have a product that's engineered to meet those needs if the customer's expectation is high.
Okay.
So there's no way to answer that. It's all over the place.
Yeah. Okay. I think we can maybe get one more in here. Somebody has asked, what are the general recommendations to impact cost in a manual powder coating process?
The number one, I would say I give three things I probably would say that are the most impactful. Having a good ground. Okay, so we're applying powder with electrostatics. We need a good ground for the paint to stick to the part. So have a very good ground. If you have to file hooks, then file hooks to make sure that we've got metal to metal contact. Have a driven ground rod at the application booth. An 8-foot copper driven ground rod. This is driven all the way down into the ground. If you've got a poor ground, if you have poor ground because of soil in your community, you may have to put 2 or 3, but in various places to try to improve the ground. You can work with your electric utility to determine how the quality of your ground as well. But I would say having a good ground and then having a good cable connecting the ground rod to the cart that you're painting on. Clean hook, metal to metal contact. So ground is number one. Number two, I showed you the powder coming out of the gun. We put as little out of the gun as you need to get the film build to the correct level in the time you have to paint it. Don't put powder on the floor because then you are negatively impacting it. And then the last thing I would say is have a film thickness gauge and use it. The other thing about gauges is they have to be calibrated. And so you have to zero a gauge out. You saw in the one picture, the gauge had shims beside of it. The shim will allow you to say, is this gauge reading correctly? So if you've got a 1 mil shim on a bare metal part and you put the gauge on there and it says 1 mil, you can trust that you're getting good readings. Those are the 3 things. Great.
Well, a lot of good information. I'm sorry we are out of time, so I know there are a few other questions here, and we'll get those over to Mike, but I do encourage you to contact him as well if there's something you need specifically right away. And Mike, if you wouldn't mind just flipping to the next slide for us. I just want to remind everyone to mark your calendar and save the date for our powder coating week in Orlando, February 23rd through the 26th in 2021. You will see Mike there as well, and I want to thank everyone for attending the webinar today. Just as a reminder to watch for the survey that comes through your email and click the link for us to give us that feedback, and we look forward to seeing you at a future PCI event. Thank you all. Bye-bye.
Thank you.
Thanks, Mike.